So if you fit these observations with some trend lines, you can see that it's linearly, or it's increasing every year. So the question is, what controls temperature? If you have more atmospheric aerosols, we have less solar radiation reaching the Earth's surface, which was basically what Trude Stormont was saying just now. And this has a cooling effect on the temperature of Earth. If you have more greenhouse gases, more radiation from the atmosphere back to the Earth's surface will have a warming effect on the temperature. And what we observe is the net effect of solar radiation and greenhouse gases, which is the temperature. Now, greenhouse gases has been increasing since the 1964 and ever since. And it's basically linearly increasing. And on the other side, or on the other hand, we have solar radiation, which has been, which is the concentration of atmospheric aerosols. And this is also changing over time. Observations since 1964 shows that we have a decrease in solar radiation until the mid-90s. In fact, 1993 had the lowest observed value of solar radiation reaching Earth's surface. This is because we had more pollution until then, and since then we have observed less pollution. And since then, solar radiation has been stabilizing or even increasing in some areas. So, what is the implication of an increase in solar radiation? What used to be a cooling effect on the temperature will now contribute to global warming. The data we use are observed values for solar radiation. It comes from the Global Energy Archive. CO2 comes from the Mauna Loa Observatory at Hawaii. And observed temperature is from the British Atmospheric Data Center. And this means that we have a so-called panel data. From an economic statistical point of view, it means that we have 1,330 individual stations with observations and 38 years of data. So this figure here shows you the trends in solar radiation. And as you can see, it seems to be decreasing until the 90s here. And since then it has been stabilizing or even increasing in some parts. The blue line is the global annual mean of solar radiation, and the red line is the solar radiation in Asia, and the green line is the solar radiation in Europe. Now you can fit trend lines to these observations as well, but clearly solar radiation will not continue to decrease linearly, because we observe less aerosols emitted to the atmosphere due to cleaner technology. So is then a linear trend the best way to represent solar radiation? From a statistical point of view, no, because we have less accurate representation of observations. So to better fit observed values, we need to use more sophisticated statistical tools. And we apply econometric models to capture trends in both greenhouse gases and solar radiation. And our approach is based on observations and not global climate models. This figure here shows the observed temperature, which is the blue line, observed annual average temperature since 1964 until 2000. The purple line is our model, how our statistical model represents the observed temperature. Now, the red line represents temperature if we observe no change in solar radiation. So if the solar radiation was constant since 1964 and until 2000, we would see a much higher increase in the observed temperature. On the other hand, if we held CO2 constant since 1964, which is the green line, we would actually observe a decrease in temperature. This is due to the fact that greenhouse gases and solar radiation pulls the temperature in opposite directions. Greenhouse gases pulls the temperature up, and solar radiation pulls the temperature down. So this means that the net effect is what you observe, which is the temperature, the blue line. This figure here shows us how global climate models represents solar radiation. The black line here is what we observe. This is observed values. The blue, the light blue and the red line are model representations of solar radiation. And we see that it's a much weaker trend in solar radiation than what we observe. And this means that models underestimate the effect of solar radiation. And if the trend in radiation reverses, predicted temperatures will be much too low. So to wrap up the talk, the temperature is affected by both greenhouse gases and solar radiation. And currently, global climate models underestimate the trends in solar radiation and will therefore underestimate future temperature. During the period from 1964 until 2000, 40% of the CO2 warming was compensated by aerosol cooling. So, thank you.